Hi everyone, welcome to the session. So this is the this is the eighth session on ray optics. So in this session, we'll do problem solving on spherical mirrors. So let us start with this question. An image of a candle on a screen is found to be double its size, which means they're saying that they're saying it is found on a screen. What does that mean? If an image is found on a screen, can we say that it is a real image? A virtual image cannot form on a screen because a virtual image is behind the mirror. If you place a screen there where the image is formed, screen on the screen image will not be formed. Only for a real image, if you place a screen at the position of image position, image will be formed. So then since they're saying that it is formed on a screen, I can say that it is a real image. And they're also saying that it is found to be double its size. Double its size means m is equal to 2 or minus 2. Image of a candle, which means a real object, no? Real object, real image. Real object and real image. When is it possible? For a convex mirror or a concave mirror?
Concave.
Concave only, no? Only for concave. When you put the object in third or fourth, only then we get a real image. For convex mirror, real object, when you place a real object, you get a virtual image. For a virtual object, you get a real image. Real object, real image case is not possible for convex mirror. So real object and real image is possible only for concave mirror. Okay. So since they are all saying that image is double the size of the object, which means magnification happened. So magnification happened. So can you tell me what is the m value? Is it 2 or plus 2 or minus 2? It can be plus or minus 2. Whenever they're saying it is doubling, it can be plus 2 or it can be minus 2. They did not say whether it is inverted or erect. But from the understanding, real object and real image, it happens only in concave mirror, and that happens in concave mirror. And that too, when you place the object between focus and pole, not possible. This is the first region, second region, first region, second region. Don't place the object if you want to get a real image. So third region and fourth region. So you have to place for a real object. If you want to get a real image, you have to place the object either in third region or in the fourth region. But they said it is being magnified, so it means you have to place the object or the candle in the third region, because in the third region, if you place the object, image is formed in the fourth region and it will be bigger in size. It will be bigger. But it will be inverted. The relation between third and fourth region is object and image are inverted. So that's why m will be magnitude is 2 units. That is clear from the given data, but it will be minus 2 because real object and real image happens only in the concave mirror. That too, when you place the object in the third region, only then magnification happens. When the magnification is happening, only inversion is happening. So that's why m is minus 2. Right. So this is the data. So what is the formula for m? Can I say that it is minus v by u? Right. So if you cancel this minus, can you tell me the relation between v and u? The relation between v and u is v equal to 2u. Image distance is 2 times the object distance on the same side. So if you know object distance, you can say the image distance. If you know image distance, you can say the object distance. Right now, they are saying when the candle is shifted by a distance of 5 centimeters, then the image becomes triple its size. Then the image becomes triple its size. Find the nature and radius of the curvature of the mirror. Nature of the mirror means, is it convex or concave? That part we know, right? We know that part. Give me a second. Okay. Right. So what is the nature of the image? We know that we have figured out that it is concave mirror because of real object, real image formation happens only in concave. So what else we want to find out? We want to find out the radius of curvature. This is what we want to find out, which means focal length, if you can find, it is as good as finding radius of curvature. Radius of curvature is equal to 2 times the focal length. So let's find out the focal length. So V and U, if you know V and U, both of them, we know the relation between them. If you know one of them, then you can figure out the F value. 1 by V plus 1 by U equal to 1 by F. We know this formula. Using this, we can find F if you know both F, V and U. Okay, but we don't know U or V, both of them. We only know the relation between them. Right. So we have to, with whatever we have done till now, analysis we have done till now, it's not sufficient to find the F value. Okay, that's why another condition is given. When the candle is shifted by a distance of 5 centimeters, then the image becomes triple its size. Then the image becomes triple its size, it seems. So what is the new case? They're shifting the object, it seems. They're shifting the object. Now, using your common sense, you know what happens when the object is traveling right side or left side, right? So from that, can you tell me, the object they are saying that it is shifted by 5 centimeters. Is it shifted towards right side or left side? They are also saying that magnification factor is minus 3 times, because negative sign should be there because we are using concave mirror. And they're saying that image is becoming triple its size, which means M is minus 3. Magnification should increase. So now tell me, instead of placing here, the object we want to move, should we move to the right or to the left? Should we move to the right or to the left? If you move to the left, as you go to the center of curvature, image also comes to the center of curvature. The magnification factor will be only minus 1 when you place the object at center of curvature. As you move away from center of curvature, object moves away from center of curvature, image also moves away from center of curvature, right? As the image moves far from the center of curvature, the farther it is, the bigger its size, right? So which means if the image is farther from the center of curvature, then the object also will be farther from the center of curvature. As you go more towards right side, as the object moves towards right side more, the image also moves towards left side more. Only then the ratio, see here. So as it goes like this, V is increasing. As it goes this side, U is decreasing. Correct? So which side should we move? Should towards left or towards right? This object, they are saying they moved it by 5 centimeters. Should it be here? Should the candle be here? Or should it be here? Can you tell me, Purnashri? Should it be here? Or should it be here? Is it the first position or
Right
second
side.
position?
First position.
First position. Wonderful. Very good. So this is the correct position. Because as you move towards the focus, as the object moves towards the focus, image moves towards the minus infinity, towards minus infinity. So as the image is farther from center of curvature, the size will increase. When the object is at focus, image is at infinity. Okay, the farther the object is, V is more. If V is more, then only the magnification is more. The image distance is increasing, magnification is also increasing. So from that, we have figured out that this is 5 centimeters. Okay. Right. Originally, this is, let's say this is X. Now, what is this value? Can you someone tell me, Magna? How much is this value? In relation with X. The original object distance is X. Now it will be
X minus 5.
5 units lesser. Correct? I'm not saying U. Mind this, I'm not saying U. Because if you use U, then U has negative sign inside it. Right? That's why X is just the length. X is just the length without any sign. Right? Now, so here, can I write it as, what is U here? What is U here? Minus X. Can I write that? In this case, U is minus X. Okay. In this case, what is U? What is U here? U equal to minus of X minus 5. Is that okay? Minus of X minus 5. Or can I write as minus X plus 5? Is that okay? U dash. Let me call it as U dash. So U dash. What is minus X? U. Can we write as U plus 5? Is that okay? The distance is reducing, but still we can write as U plus 5. Why? Just when you are getting confused with sign, just take some value which does not involve sign, this length part. If this is x, this will be x minus 5. So if you're talking about the image object distance, in this case, object distance is, when you're talking about real object, it is you have to take minus of the length. The length is x minus 5. If you take minus of it, it is minus x plus 5. So you can write as u plus 5. Okay. Now in this case, what is the relation? M is equal to minus 3, which means minus v by u is minus 3. This implies v equal to, sorry, v dash, let me call it as v dash, because v and u we have already used. So v dash by u dash. So v dash is equal to 3 times u dash. And what is u dash? What is u dash? U plus 5. Correct? Okay, but what? Yeah. V dash is 3 plus 3 into u plus 5. Okay, agreed. Now with the information that we have, v equal to 2u. Okay. So we got v dash. So I think we have to eliminate with this v dash. Then only we can. There are two variables here. There are two variables and two equations. We can solve them. We can get the final values. What is the v dash here? It becomes triplet size. How to eliminate v dash? Or am I complicating it by unnecessarily using all this, because they are talking about only magnification factor? Okay, but anyway, let's try to solve it. One by, in place of v, I'll write it as 2u plus 1 by u is equal to 1 by f. So 1 by 2u plus 1 by u is 3 by 2u, right? Equal to 1 by f. Fine. Now here also let us do the similar thing. 1 by v dash plus 1 by u dash is equal to 1 by f. So I'll write in place of v dash, can we write as 3u dash plus 1 by u dash. What is u dash? U plus 5, right? U plus 5 is equal to 1 by f. So 3u dash, and u dash, in place of u dash I've written u plus 5. Let's eliminate this u dash. Let's write only in terms of u only, so that only one variable will be there. It will be easy to solve. So tell me this. How do you write this? V dash, we have written it as 3u dash. V dash is 3u dash, which can be written as 3 into u plus 5. Yeah, we have v dash, we have already written. V dash, in place of v dash, I'm replacing it with 3 into u plus 5 plus 1 by u plus 5 is equal to 1 by f. 1 by f we already know, we have written, we can write it as 3 by 2u. Okay. Now let us simplify this. I think we got it. So 1 by 3 plus 1. 1 by u plus 5, if you take it common, what is left is 1 by 3 plus 1, which is 4 by 3. Which is 4 by 3 is equal to 3 by 2u. Which is 3 these are 9 onto the one side. 9 into u plus 5 on one side. This u plus 5 onto the other side. 3 onto the other side. 3s are 9. 9 into u plus 5 is equal to, this 2u into 4 is 8u. So 8u onto the other side becomes u is equal to 9 5s are 45. It is minus 45 centimeters. Is that okay? U is minus 45 centimeters, but we don't want U, we want F. F is equal to 2 times U by 3. 2 times, any calculation mistake from my side? No, right? 3 3 9, 9 plus 45. Okay, agreed. 2 into U is minus 45 divided by 3. 3 ones, 3 15s. 15 twos are 30, minus 30 centimeters. Is that right? Yeah. Now what is R? From that you can write, tell what is R. R is 2F, which is minus 60 centimeters. Okay. We could have done it faster actually. So based on what idea we get, how we apply it. So maybe I have not done it the best way possible, but whatever way you do, we should be able to get the answers. It depends on what idea we get at that point of time. If we get a better idea, we can solve it faster. Okay, so okay, what if we try the other way? Let's try to do it other way. So I hope you know the formula for magnification factor, right? V equal to UF by U plus U minus F, right? So how about V by U? V by U. U onto the other side is equal to F divided by U minus F. Magnification factor is equal to minus V by U, which is minus F divided by U minus F. I would suggest not to remember this formula minus F by U minus F. It will become too many formulas. So just take this one. That is sufficient. So you can send U onto that side and apply minus sign. That will give you magnification factor formula. But if you can remember everything, yes, you can try to remember. But I would suggest not to remember too many things. Right. First case, magnification factor is minus 2 is equal to it is given as minus F divided by U minus F. Correct? Minus gets cancelled. Next, in the second case, it is given as minus 3 is equal to, same focal length will not change when the object position changes, focal length will not change because we are talking about the same here, right? F divided by U changed. And how is the U changed? The new value of U is U plus 5. U plus 5 minus F, correct? So I think now it's easy to, yeah, this is minus F by U minus F. Minus gets cancelled. So from this, 2U minus 2F is equal to F. 2U is equal to 3F, right? 2U is equal to 3F, or U is equal to 3 by 2F. Same thing we got here also, some other, using other procedure also. So from here, let's send this on to the other side. 3U plus 15 minus 3F is equal to F. Okay. So what is 3F? 3F equal to 2U, right? You can substitute 3F with 2U. This is 2U. 3U minus 2U is U plus 15 is equal to F. Correct. Yeah, what we want is F. So let us replace U with F relation 3 by 2F. If you replace U with 3 by 2F plus 15 is equal to F. So 3 by 2F, the F this side, it will become F by 2 is equal to minus 15, F equal to minus 30. Yeah. If we had used magnification formula, then I think we could have saved another 1.5 minute. Okay. Any doubt? Meghna?
No, sir.
Are you following?
Yes, sir.
So here, one thing important to note is whenever they say object is moved, which side it is moved, you have to understand that. So left side or right side, one thing. Once you say that it is left side or right side, since in this case it is moved right side, immediately we think that it is U minus 5 is the object distance, we think. But object distance is measured negatively. When you are measuring negatively, this distance is increasing negatively when you're talking about negative values. So this distance is minus x. This is minus of x minus 5. So you may think that it is u minus 5, but actually it's not u minus 5, it's u plus 5 because of the negative sign that is there in u. Okay, whenever you're confused, whenever they move this side or that side, since object distance or image distance might be negative, in those cases you have to be careful with the sign. It might look like u minus 5, but that's actually u plus 5 because there is a minus sign internal to u. So in such situations, if at all if you're confused, what you can do is instead of u and v, take some length, take some value of length, and let's say something like x or y, which will consider only the length. So it will not consider the sign. Then it is easy for you. This is x, this is x minus 5. So then you can understand it in terms of u. U is minus x, this will be u minus of x minus, something like that. So in these kind of problems, the trick is instead of putting u plus 5, if you have put u minus 5, we will not get the answer. Okay, so that's why we have to be careful in these kind of problems in this sign. Okay, so I'm moving further to the next one. This is point object. Point object is placed 60 centimeters from the pole of a concave mirror of focal length 10 centimeters. Can someone quickly tell me? Is it in what is it? In which region is it placed? The object is placed in which region? Just by looking at the question, you can say, right?
Beyond
Beyond center of curvature or fourth region, correct? Because
Yes.
10 centimeters only in a focal length. Center of curvature is at a distance of 20 centimeters. Anything beyond 20 centimeters, it is in the fourth region or beyond center of curvature. Right. So now quickly, can you guess where is the image location?
third region.
Third region. Or can you guess what is the value of V? If you find out V, what is the value that you can get?
Between 10 to 20.
10 to 20 or minus 10 to minus 20?
Minus 10 to
Minus
minus
10.
So I think we have some answer in our mind, no? So with this analysis hardly takes 10 seconds. If to our luck, if at all, if in the options, if there is no option which is, if there is only one option between minus 10 and minus 20, you can quickly pick it up. You don't need to do any calculation also. If we are lucky, okay. If there are two options between minus 10 and minus 20, then maybe we have to solve it. Okay. Right. So focal length is 10 centimeters. This is 10. Right. Now, what is the position of image? It's very easy, no? What is the position of image? What is u value? When a point object is placed somewhere here. V is very easy to calculate. So who will tell me the V value quickly? This is at a distance of 60 centimeter, minus 60.
minus 12.
This is the object. Sorry?
Minus 12.
Minus 5.
12.
Minus 12. Okay, yeah, that should be fine. UF by U minus F. Substitute the sign correctly. Without substituting with sign, you will get wrong answers. U is minus 15. And what is the F? F is minus 10. Mind this. Focal length for concave mirror is negative. So U is minus 60 into minus 10 divided by minus 60 minus of minus 10. So minus into minus is plus 600 divided by minus 60 plus 10 is minus 50. So it is minus 12 centimeters. V is minus 12 centimeters. Okay, fine, we got it. V is there, U is there, fine. So first question is done. Let's do the next question. Question B, what they're asking is, if the object is shifted 1 mm towards the mirror along principal axis, then find the shift in the image. Any ideas? Any ideas? Yes, we can go ahead with the very basics. What is U now? They are shifting now. They are saying that they are moving the object. They are moving the object instead of this position. They are moving into this position. They're moving into this position. And how much they're moving? Only 1 mm they are moving. They're moving into this position. Originally it was here. Now they have moved it to here. They have moved it like this. Same mirror, same focal length, everything same. Right. So, okay, we can go from with the basics, but if you get some idea, it will become easy. Otherwise, we can go with the basics. What is 1 mm means? 1 centimeter is 10 mm. So which means, can I say this is the position is 59.9 centimeters? Is that okay?
Yes.
So U is minus 59.9. So if you want, you can do substitution as UF by U minus F, which is minus 59.9 into, see here, we are not converting into SI units because it's not required, because focal length also in centimeters, object is also is in centimeters. So you can substitute them in centimeters itself. Don't need to substitute in meters. If you substitute in meters, it will become complicated because multiplication with decimal points will be trickier. So because all of them are in centimeters, see, this is in meters, this is in meters, this is in meters, this is in meters, then also you get the same result, similar result. So if all of them, if you make, there is nothing wrong in doing in meters, but since all of them are in centimeters, you can deal with it in centimeters only, because this is in centimeter, this is in centimeter. Unit of the numerator centimeter square, unit of denominator centimeter, centimeter square can cancel, resultant unit will be centimeter. Since you are substituting everything in centimeters, result also will be in centimeters. Okay, so try to follow only a single unit. Even if they have given in mm, since you are using, you have to use a common unit. So for whatever they have given is in mm, try to convert it into centimeters. If at all, if they are giving all of the many values in meters and some values are in centimeters, then you can convert everything into meters and meters. But mostly focal length means generally they are giving centimeters only. Very rarely we have 1 meters of focal length. Okay. Mostly the problem will be given in centimeters, focal length, radius of curvature. These all of them will be in centimeters. So try to convert, if at all they have given something in meters also, try to convert it to centimeters. Into minus 10. Focal length will not change when the object is changed, its position. It's minus 599 divided by minus 49.9. So what is the answer? It is something close, very close, correct? So we have to take the help of calculator.
Plus 599.
Sorry?
Minus into minus plus in the numerator.
Okay, fine. In the numerator is plus, agreed. So tell me this: should it be more than, means the value should be a little higher than 12 or less than 12 magnitude wise? That we can say with common sense also. No? As you move towards the center of curvature, object also moves. This object also moves. Sorry, but this object, the image is here. Image is here. This is the location of image. This is the location of image. As the object moves towards the center of curvature, image also moves towards the center of curvature. So the magnitude wise, it will be more than 12. That much I know. In the options, if there is only one option which is very close to 12, something like minus 12.1 or 12.01, something like that, I will pick that option without doing any calculation. But there is a better way to do this. What is that? So if you remember, as you move longitudinally, think of this as length of the object. Is that okay? Longitudinal length. When the length of the object is very small, actually this is not object whose length is small. We have moved from one position to another position. If you have moved from one position to another position, what is wrong in treating it as a single object? Whose one end is one point, another end is another point. If this is L, then center of curvature, its image will be something like this, but it will be much smaller than this. Length of the object, this is length of the image. So could you tell me what is the relation to length of object and length of image placed on the principal axis? That is what we call as a magnification factor. Magnification factor longitudinally. It is length of the object, length of the image divided by length of the object. And how much is that? When you place perpendicular to principal axis, magnification factor is minus v by u. But when you place along the principal axis, magnification factor is, what is it?
Minus
For
V2.
small objects. For small objects, it is m square. I'll go back. I'll show you. What is it? Longitudinal magnification. When you place an object longitudinally along the principal axis, if it is small, the formula is simply what transverse magnification factor minus v by u square of it. Okay. Or if the object is bigger, it is like take the two endpoints, find their images, take the subtraction. That is how you do for bigger objects. For bigger objects, there is no shortcut. Okay, you don't need to remember this formula. Also. Take two endpoints of the object, find the images of those two endpoints. You'll get the endpoints of the image also. If you know the endpoints, you can measure. You can get the length of the object, length of the image. Just do the division. You should get the magnification factor. But for small objects, there is an approximation. V2 minus V1 we can write as dV. V2 minus V1 we can write as du. And we know what is dV by du. It is v square by minus v square by u square. So if you got this idea, this problem would have been like a 5-10 seconds problem. So what is the magnification factor? Can you tell me? V is minus 12. Magnification factor is what? Minus v by u whole square. So v is 12 divided by u is 60 minus 12 by minus 60 whole square. So which is 1 by, this is 12 ones, 12 5s, 1 by 25. So length of the image is equal to length of the object divided by 25 times. Sir, here it's not length of the object, no, here is only point object is moved. Okay, fine. So if this length is L0, if this is the length of the object, length of the image. So originally it was at this point, originally the image is here. It will move to this place, no? This movement, how much is this? It is length of the object. How much is it move? 1 mm. Originally it is 1 mm. It is 1/25th of the mm. It is 1/25th of mm. So they're asking only shift in the image. They're only asking shift in the image. How much is the shift in the image? It is only 1/25th of an mm or 0.04 mm. Is that okay? So shift in the image is 0.04 mm. Though it is like a point object is shift, you can think of it as a big object and you find its image. And that way also you can find the shift in the image. I hope you're following. Any doubt here? Question? Narahari? Am I following or not?
Yes.
So this magnification factor comes in handy whenever you observe these small lengths, 1 mm in mms, then you can take the help of longitudinal magnification. But when you go with a very, very basic procedure, this calculation we can't do because for you in your exam, calculators will not be given. So finding this will be very, very tough. Okay, so if at all, if you want to image position, it will be minus of 12 plus, because it moves this side, 12 plus 0.04 mm. So it's 0.04 mm.
0.004.
Yeah, this is 0.04 mm, 12 centimeters plus 0.04 mm. So let's convert them into both same units, then it will be 0.004 centimeters. Okay. Fine. I'm moving on to the next one. Try this one. First, what are they asking? Find the size of the image if the object size is 1 centimeter. Size of the image they are asking. So here they will have some confusion. So is the object placed longitudinally or transverse? Is it placed longitudinally or transverse? Nothing is mentioned here. Okay, nothing is mentioned. By default, we generally place the object perpendicular to principal axis. We generally place the object perpendicular to principal axis. So okay, the mirror is given as convex. Okay, I've drawn it as concave. Focal length is 12. So if it's plus 12 centimeters, mind this, it is convex mirror, so I'm writing it as plus 12. So real object, so the object is placed here and its height is given as 1 centimeter. So if they don't mention specifically that it is being placed longitudinally or on principal axis, if they don't use the word along the principal axis or longitudinally, it means they are by default the question is about perpendicular to principal axis, they are placing the object. Now when the object is placed here, image is placed, image will be, when the object is in the first region, there is first region, second, third and fourth. The object is in this region, image is formed in this region between pole and the focus. Okay, and we know whatever is in the first region, whatever object is in this region, that will be bigger always, whether it is image or object, whichever is in this region, that will be bigger. So the image is formed here, which is virtual image. It will be smaller than this, we know that much. So the object size, image size will be definitely less than 1 centimeter, that much we know, but how exactly it is, that we can't tell at this point of time with the given information. We can, with the given information, we can use the formulas and we can tell that exact size, you can see. So object distance we don't know, image distance also we don't know, but they have given us some information. What is the information given? The distance between these two is given as 32 centimeters. The distance between a real object, this is real object, this is virtual image, it is given as 32 centimeters. Find the size of image if the object size is 1 centimeter. Fine. So now, just to make things clear, let us take this length, only length as x, this length, image distance as y. Okay. Now tell me, what is u here? If you assume this length, only length as x, so u, because it is real object, sign will be negative. Can I write as minus x? And how about v? What is the image? It is on the, it is behind the mirror. It is measured. It is measured. It is behind the mirror. Anything behind the mirror, we measure it positively. So it is plus y. So focal length is given. Okay. So we have a formula: 1 by v plus 1 by u is equal to 1 by f. And let us substitute. What is 1 by v? 1 by v is 1 by minus x. Sorry, minus plus y. Right. Plus 1 by u is minus x is equal to 1 by f. F is what? Minus 12. Sorry, plus 12 minus. F is plus 1. Okay. So what is the relation between x and y? X plus y is given as this length plus this length is given as 32. That is the given data. Now minus to the numerator. Can I write as x minus y divided by xy is equal to 1 by 12. Okay, is it wise to solve like this? No, it's better to solve it like this. Y is equal to 32 minus x. Is that okay? We can substitute it here. Y is 32 minus x plus 1 by x plus minus 1 by x. I'll send this minus 1 by x onto the other side. 1 by 12 plus 1 by x. Minus 1 by x onto the other side, it will become plus 1 by x. So this is 12 plus x divided by 12x. So why am I not solving it here itself? This minus 1 by x, if I'm putting here, I might be getting some quadratic. So see, I'm trying to avoid that quadratic so that it will become easy to solve. So 32 minus x. Okay, we can't avoid the quadratic. I think now also they are getting it. So 12x onto this side 32 minus x onto the other side. So 32 minus x into 12 plus x, which means there are two solutions for this. So 32 into 12, how much is that? 32 into 10 is 320. 32 into 2 is 64. 320 plus 64 is 384. Right? Correct me if I have written anything wrong. 32 into 12 is 384 minus x square. So this is minus 12x plus 32x is plus 20x. 32x plus minus 12x is plus 20x. So I'm sending this x square onto the other side. X square. This plus 20x onto the other side becomes minus 20 plus 12 is minus 8x. Minus 384 is equal to 0. So what is the, divide this further, 384. Can you tell me the factors for this? What are the factors for this? Let's divide into 4. 4 9s are 36. 36 24. 4 6 are 24. So the difference between them is not 8. So this is not okay. So let's divide this into further 4 16s. Yeah, now it's fine. So factors are 4 4 16. So let's write this 384 as 8 into 16. Sorry, 16 into 16. No? 16 is 256, right? 4 9s are 36. 4 6 are 20. 16 6 are, yeah, minus 6. Yeah, now we can write it as 4 6 are 24 into 16. We can write 384 as 24 into 16. Yeah, if it is minus 384, we can write as minus 24 into plus 16. Yes, we can write it as x square minus 24x plus 16x minus 384. If you have an easier way of getting the roots, you can do it. Minus b plus or minus root of b square minus 4 is equal to it. That also you can use. Whichever you are comfortable, you can use that. X into x minus 24 plus 16 into x minus 24 is equal to 0. So the solution is x equal to 24 comma minus 16 plus 24 minus 16. What is okay? X is just length. It should be positive only, right? It should be positive only because x is length. We know that while we are assuming itself, we have treated x as positive only. What is the answer for x? X is 24. Okay. So x is 24 means what is u? U equal to minus 24. And what is v? V is plus y. If x is 24, what is y? Y is 8 centimeters, correct? Plus 8 centimeters. So magnification factor is equal to minus v by u, which is minus of v is 8, u is minus 24, it should be 1 by 3. So magnification factor is 1 by 3. So size of the image. What is the meaning of magnification factor? Magnification factor means m is equal to size of the image, height of the image divided by height of the object. That is what is magnification factor, which we got it as 1 by 3. So height of the image is equal to height of the object divided by 3. Height of the object is given as 1 by 3. Sorry, 1 centimeters. If you substitute that here, it is 1 by 3 centimeters is the height of the image. So this is the answer. Okay. Any doubts, Magna?
No, sir.
No, sir. Understood.
Okay, 1 second. Okay, so let's try this one. Object AB is placed on the axis of a concave mirror of focal length 10 centimeters. So focal length is 10 means some object is here. This is focal length 10. Center of curvature is here. See? And A of the object is at 30 centimeters from the mirror. Find the length of the image if the length of the object is 5 centimeters, if the length of the object is 1 mm. There are two questions here. In the first case, object length is 5 centimeters. This length, if you observe, this is comparable to focal length. Focal length is 10, object size is 5. So you can't treat it as a small object. So what should we do now? We have to treat it like normal object. We have to go with the basics. You have to, if you want to solve the first question, you have to go with the basics. Question A, let's solve. Let us go with the basics. How do you treat it? So take one end and take the other end. Okay, let me call it as point 1 and point 2. And just endpoints. Extended object, how do we deal with it? In extended object, take the endpoints, find their images. That is how you can find the length of the image also. So for 1, you find the image. It will be somewhere here. The closer it is to center of curvature, closer the object is to center of curvature, closer of the image also. It is point 1's image. This is point 1's image, and this is farther. This point is farther from center of curvature. Image of second point is somewhere here. Image of second point is somewhere here. Okay. So if the direction is given something like this, then the direction for this is given something like this. So this is how it is. It is smaller in size. We know that. Whatever is between center of curvature and focal length, it will be smaller compared to whatever is in the fourth region between C and minus infinity. Right. So now we treat it as two problems. One as finding the image for first, finding the image for the first point, finding the image for the second point. Okay. So let us do the problem for first point. Let us do the for first point. 1 by V plus 1 by U is equal to 1 by F. Focal length we know. So how much is the focal length? Focal length is given as 10 centimeters. Is it minus 10 or plus 10? Because it is concave mirror. Focal point is here. In front of the mirror, anything in front of the mirror, in front of the polished side, it is negative, minus 10 centimeters. Okay, so what is given about, what do we want? We want the image, right? Image means, yes, you can use this formula, or else instead of this, let us use this formula, which is more easier. UF by U minus F, that's better. No? For this point, what is U? U is 30 centimeters, that is what is given. For this point, U is 30 centimeters, that is given in the problem. Sorry, it is 30 or minus 30? Minus 30. Real object, it is negative. So it is minus 30 into minus 10 divided by minus 30. Minus of minus 10 is plus 10. So how much is this? Minus into minus is plus. It is 300 in the numerator divided by minus 20. So 0, 0 cancelled. It is minus 15 centimeters is the image distance. Minus 15 centimeters is the image distance. So this is the image distance for the first point. Let us deal with the second point also. Same formula. So what is the object distance, anyone? We're talking about A, question A. We're talking about question A here. We're talking about question A here. What is the point 2? This length is given as 5 centimeters. In the first question, the object length is given as 5 centimeters. Okay. If it is given as 5 centimeters, can anyone tell me what is the object distance of the second point? This is 30. This is 5. So total it is minus 35 centimeters. Okay. This point is given as 30 centimeters away from the pole. This point is given as 5 centimeters. This length is given as 5 centimeters in the first question. Okay. So my U is minus 35. So what is V? V equal to UF by U minus F. U is minus 30 into F is minus 35 into minus 10 divided by minus 35 plus 10. So tell me the calculation. Okay, right. So it is minus 25, you divide it. So 25 is 4, 4 is 12, 13, 14 centimeters. Okay. So this is V for point 2. This is V for point 1. This is V for point 2. So we got this length we got this length, which is V2, sorry, V1, and this length we got, which is V2. So just take the subtraction. Take the subtraction, it is only 1 centimeter. No? So these 2 points that are having a length of, or at a distance of 1 centimeter, which means 1 centimeter is the length of the image. If the length of the object is, find the length of the image. Here, length of the image is 1 centimeter. Okay. Is it okay? Clear?
Yes, sir.
Yes.
So how about B? B should be more easier. Right? If the length of the object is only 1 mm, length is only 1 mm, it seems. For small size objects placed on the principal axis. For small size objects placed perpendicular to principal axis, there is no shortcut. Basic formula only, m equal to minus v by u only. For objects placed perpendicular to principal axis. But here, the object is placed on the principal axis, parallel to principal axis. So what is it? Height of the image, sorry, length of the object and length of the image. What is the relation? Length of image placed on the principal axis is equal to, how much is it? M square times length of object. Correct? Are you following?
Yes, sir.
Longitudinal magnification is equal to length of image divided by length of object, which is given by m square or v by u whole square. Right? So what is m square? M is given by minus v by u. What is m? Can you tell me what is m? We already know first for first point. For this point we have tried. This point given distance is given as 30. So this second point's distance will be only 30.01 centimeters. Okay. So there is no need to treat them as 2 points. You can take the help of longitudinal magnification. So what is the magnification? V is minus 15 and what is u here? Minus 30, right? So what is V? Minus V by U. Minus V is minus 15 divided by U is minus 30. So it is 1 by minus 1 by 2, correct? So it is 1 by 2 minus 1 by 2 whole square into length of the object is 1 mm, which is equal to 1 by 4 times 1 mm, which is 0.25 mm. Is it okay? If it is small sized object, you can take the help of longitudinal magnification like this. Or if it is bigger object, if you can't treat it as a small object, then you just take 2 points, treat them separately. For this point, you find the image. For this point, you find the image. You know the images of both the points. Find the distance between the images of both the points. These 2 points have 2 points as images. Distance between them will give you the length of the image. Is it okay? Can I move to the next one?
Yes, sir.
Purnashri?
Yes.
Okay. Let us do one more problem based on velocities. Radius of curvature is 20 centimeters, it seems. So this is C. So this is F. Are both moving with velocities. A mirror of radius of curvature 20 centimeters and an object which is placed at a distance of 15 centimeters are both moving with velocities 1 meter per second. See here, 1 meter per second. 1 meter per second is the velocity of the mirror. Mirror is also moving here, mind this. And 10 meter per second is the velocity of the object and it is moving away from the mirror. Find the velocity of image in this situation. So since they are moving parallel, to principal axis. They are moving parallel to principal axis. So we always measure things with respect to the mirror. So what is the relation between velocities? Longitudinal relation between velocities. Do you remember that? Longitudinal relation between velocities. 1 by v plus 1 by u is equal to 1 by f. I will do the derivation also if required. So if we differentiate everything with respect, since we are dealing with velocities, v and u are not velocities here in optics. V and u are object distance and image distance. So if you differentiate with respect to time, it is minus 1 by v square into dv by dt plus minus 1 by u square into du by dt. We have done this derivation yesterday also. Differentiation of this constant is 0. So this is dv by dt, which is the velocity of the image with respect to mirror, is equal to minus v square by u square. I'm sending this on to the other side into du by dt. So u is the object distance measured from the mirror, measured from the pole of the mirror. Okay. So this is velocity of the image with respect to mirror, is equal to minus v square by u square into velocity of object with respect to it. Okay, when they're asking velocity of image, they're asking about velocity of image with respect to ground. Here, whatever they have given is object velocity with respect to ground. They have given us, but in the substitution, whatever we are gonna deal with, because v and u are the displacements with respect to the mirror. So velocities that we are having in this corner, whatever velocities we are gonna have are the velocities with respect to the mirror. Mind that. So velocity of image with respect to ground is what they are asking us. Okay. So velocity of image with respect to mirror, can we write it as velocity of, okay, velocity of image, we'll find it first, or else velocity of image with respect to ground. We can write as velocity of image with respect to ground minus velocity of mirror with respect to ground. Okay, so velocity of mirror with respect to ground is given minus v square by u square, object distance, image distance, object distance. The velocity of object with respect to mirror can be write as velocity of object with respect to mirror, can be write as velocity of object with respect to ground minus velocity of mirror with respect to ground. Is that okay? Now tell me substitution. Velocity of image with respect to ground is what we have to calculate, minus velocity of mirror with respect to ground. Can you tell me how much is that? Right side moment, can we take it as positive? Velocity of image with respect to ground, let us take it as positive. Right side moment, we take it as positive, 1 meter per second plus 1 meter per second. So velocity of object with respect to ground, shall we take it as minus 10 meter per second, because it is moving left side, right? So velocity of mirror with respect to ground is plus 1 minus v square by u square. We have to use u, we know, but v we don't know. So velocity of object with respect to ground is given as minus 10. Velocity of mirror with respect to ground is plus 1, right? So velocity of image with respect to ground, if you want to find out, this plus 1 onto the other side, and this minus 10 minus 1 is minus 11 into this minus v square by u square is there. So what is this minus v square by u square? U we know. What is the u value? U value is 15 centimeters. Since it is on the polished side of the mirror, we can write it as minus 15 whole square. What is v? When they are moving at every point, they're at some position. They're talking about at the position when they're at 15 centimeters. They're talking about velocity of image and velocity of object. After some time, the object might be at some other position at 16 centimeters, at 17 centimeters. So they're asking us the question about when the object is particularly at 15 centimeters. Image will be a particularly at some location. That is what is the v value. So we have to go with the basics. Formula for v is uf by u minus it. Let us substitute and find the image location. So u is minus 15 and focal length. Focal length is, what is the focal length? 10. No? Oh, okay. Radius of curvature is 20 means focal length is minus 10 because it is concave. I've written as minus 10. Minus 15 into minus 10 divided by minus 15 plus 10. Minus of minus 10 is plus 10. So this minus into minus is plus 150 divided by minus 5, which which is minus 30 centimeters. So v is minus 30 whole square. Okay. Now let us, can you quickly calculate other things and tell me the answer? So this is equal to minus 1. This minus into minus. This minus, the minus 10 minus 1 is minus 11. This minus into minus becomes plus 30 square by 15 square. 30 by 15 whole square into 11. So this is 2. 30 by 15 is 2. 2 square is 4. 4 into 11 is 44. 44 plus 1 is 45 centimeters. 45 meters per second. Yeah, since everything is in meters. Okay. Okay. It's not in meters, but this 1, and this is 1 meter per second. This is 11 meter per second, but this is in 30 centimeters. 15 also in centimeters. Centimeter by centimeter, those centimeters gets cancelled. So effective unit will be meters only. So meter per second. Okay. So 45 meter per second is the velocity of the image. Let's understand with common sense. Is it agreeable answer or not? See, when the object is in the third region between F and C, it will be smaller. Okay, and the object in the image or object whichever is in the fourth region, that will be bigger and its velocity also will be larger. Anything, object or image in fourth region will be bigger and its velocity will be higher. So when the object is in third region, image is in the fourth region, image is in the fourth region, and image in the fourth region will have bigger size as well as higher velocity, because by the time object goes from F to C, object will go, image will go from minus infinity to C. It travels a large distance in the same time, which means velocity will be very huge. So we got a higher velocity. Is that correct or not? Object velocity is 10, image velocity is 45. Convincing. It should be higher, that much we know. If it is higher, does not mean that it is perfect answer, because we might have done some calculation mistake also. If you have got it as 40 also, it is convincing for us. But if at all, if you get something less than 10, then we can say that this is wrong. We have done some calculation mistake. If at all, if you get something less than, because image velocity should be bigger, because image is in the fourth region. Anything in fourth region should have higher velocity. Is that okay? Understood? Simple relation between velocities, nothing more than that. Simple relation between velocities, but the velocity that we have here, dv by dt, is not the velocity with respect to ground, it is with respect to mirror. With respect to mirror means you can write as velocity of image with respect to ground minus velocity of mirror with respect to motion in a line. Relative velocity concept we are using, little bit of relative velocity concept. Okay, any doubts, Purnashri? Narahari? Following or not following? Meghna?
Understood.
Okay, let us try this one. Focal length is 5 minus 5 comma 0 is the point focal length. Center of curvature is at minus 10 comma 0. The object is at minus 40, this location. This is the location of the object. It is not on the principal axis, mind this, the object is not on the principal axis, it is higher, it is at a higher position. Can you guess where is the image? Just not the exact location, but can you guess in what region it is?
Between C and
Between C and F. And what will be the position of the image? Means it will be upside of principal axis, above principal axis or below principal axis?
below.
Sorry, below, correct?
Yes.
Yeah. So it is, so see this is a point object only, but treat it like an extended object now. So though it is like a point object, to treat it like this, it is looking like this. If there is an extended object like this, the image will be something like this now. Correct? So it should be smaller. So let me draw it smaller. If there is an extended object like this, then its image will be something like this, and the image will be here, somewhere here. This is the image, which is a real image. Okay, so instead of extend object, they're saying just the point. So point is here means, the point is here means its image will be somewhere here. We know when you place an object in this region, image is formed in this region, image will be smaller. If it is an extended object, it will be smaller extended object, which means whatever is this length, which is this, it is given as 1 centimeter. Compared to, if this is 1 centimeter, the object is at 1 centimeter higher than principal axis. Can you tell me about, what can you tell me about the image position? We know that it is below principal axis, that much we know, because external object will be inverted. So which means the point above the principal axis will have an image below the principal axis when you place the object in third or fourth region, because the image will be inverted. So can you tell me, if this is 1 centimeter, the position of the image is below principal axis, and can you tell me that how far it is from principal axis? More than 1 centimeter or less than 1 centimeter? Is it more than 1 centimeter or less than 1 centimeter?
Less than.
Less than 1 centimeter, because we know an image will be diminished. You know, an object is placed in this region, image is formed in this region, it will have the characteristics of inversion, inverted image, and it is real image, and it is diminished image. So which means this point will be closer to principal axis. Treat it like an extended object only. Okay, though it is a point, treat it like an extended object. So fine. So to find the magnification factor perpendicular to principal axis, magnification factor is given by minus v by u, correct? Which is actually the, what is this magnification meaning? Height of the image. When you measure the height with a perpendicular to principal axis, height of the image and height of the object, that ratio is what as magnification factor. So what we want is position of the image. So height of the image, if you want, find this magnification factor m and multiply it with height of the object. Height of the object in this case is given as 1 centimeter, 1 centimeter higher. Now, if you multiply the magnification factor, you will know how far this point is from the principal axis. This length we will get. So magnification factor we want. So to find the magnification factor, and let's find the image distance. V equal to uf by u minus f. And what is the u value? U value is given as minus 40. And what is the focal length? Because it is concave, it is minus 5. They might say only 5 centimeters, but we have to take with sign. If it is concave, it is minus sign. If it is convex, it is plus sign. Why? Anything in front of the polished shape, polished side will be taken as negative length, negative distances. So minus 40 into minus 5 divided by minus 40 minus of minus 5. So this is 40 into 5 into 5 divided by minus 35. 5 ones, 5 sevens. This minus 40 divided by 7 centimeters is the V value. So magnification factor is minus V by U. So minus V by U is minus 40 divided by 7 divided by F is minus 5 into 1 centimeter. So 5 ones, 5 eights. So this is plus 8 by 7 into 1 centimeter. Okay. Any mistake from my side? I got it higher. It can't be possible now. Okay, my mistake. Minus of minus 40 by 7 divided by minus 5. It will be minus. It should be less than 1, no? Why are we getting more than 1? Oh, u value is substituted. My mistake. U value of substituted as minus 5. U value of substituted as minus 5. It's not minus 5, it's minus 40. Okay. So just so just 40 gets cancelled, minus gets cancelled. It is minus 1 by 7 into 1 is minus 1 by 7 centimeters. Okay. So what is the position? Can you tell me? Anyone can tell me the coordinates of the position? X coordinate. At what point is it? It is at minus 40 by 7 centimeters. That is the x coordinate. What is the y coordinate?
Minus 1 by 7.
Minus 1 by 7. Minus 1 by 7 centimeters. Okay, that's it. Very good. Let me move to the next question. Yeah, let us do this. They have given the object, location, focal length is given as f. If a plane mirror is placed perpendicular to the optical axis at a distance of, here is the plane mirror, which is at a distance of 4 by 3f from the pole, facing concave mirror. Find the position and nature of the final image formed. So this is 2 mirror case. So we know how to deal with only one mirror, either plane, concave or convex, but here there are 2 mirrors. Okay. Okay, fine. So see, for this image, for this object, will there be any image from this mirror directly? Rays from this object, can they reach directly the polished surface of this mirror directly? Is it possible?
No.
No. So because this object is behind this mirror, so direct image will not be formed for this object because of this mirror. But rays from this object will reach this mirror, and hence an object image will be formed because of this mirror. But rays which are reaching this mirror after reflection, they'll be touching this mirror also. Rays after reflection. Reflection means reflected rays are because of image. Reflected rays, the reason for reflected rays is the image. Either the rays, if there is real image, they go and intersect at that point, we call it as real image. Okay. If it is not real image, it can be virtual image where the rays appear to come from that point. So incident rays, the rays which are incident on the mirror are because of the object. The reflected rays, the source for reflected rays is the image. So the image of this mirror, because of this object, there will be some image for this. That image will act as object for this mirror. You can read it like that. When there are 2 or 3 mirrors, and there are multiple optical elements. Okay, see where the rays are first falling. Okay, you find the image of that element. Whatever is the image of that element, that will be here as object for the other element. Okay, but the tricky part here is we should always measure distances with respect to whatever mirror we are analyzing. Okay, now you'll understand. When you're trying to find the image for this mirror, you measure distances only with respect to this mirror. And we are trying to understand the image with respect to this mirror. Try to measure everything with respect to this mirror only. Let them give any number of mirrors. You follow this basic, you'll get the answer. Let them give any complicated problem, any number of mirrors, same procedure. Our image of one mirror will act as object for another mirror. Okay, but whatever image distance that we are going to get will be with respect to whatever mirror we are analyzing. Okay, so right, let's do this problem, and if possible, we'll do one more problem, then you'll get more clarity. Right, so the rays from this object will reach this mirror. Okay, will reach this mirror. Now let's find the image with respect to this mirror. So with respect to concave mirror, let's analyze the image with respect to concave mirror. There are 2 mirrors here. So let's analyze first with respect to concave mirror. For concave mirror, what is the object distance? When you're analyzing with respect to concave mirror, you have to measure everything with respect to the pole of the concave mirror. From concave mirror only we have to measure. So distance are also already given with respect to concave only. So our job is easy. How much is u value? Can you quickly tell me? Minus 5 by 2f.
Minus 5 by 2.
And so what is the focal length? Focal length is minus f. Is that okay? Only length is f. With sign, you have to write it as minus. So, but object distance, this mirror distance, they're all given in terms of f. F is this one, this length is given as f. Okay, if this length is f, then this is pi by 2f, this is 4 by 3. They have not taken sign into consideration, we have to take the sign. So from this, can we find the image distance? V equal to uf divided by u minus f, which is u is minus 5 by 2f into minus f divided by minus 5 by 2f minus of minus f. What is v value now? So it is minus into minus is plus 5 by 2 f square divided by minus 5 by 2f plus f is minus 3 by 2f. Is it okay? Minus 5 by 2f. This is plus f. 5 by 2 plus 1 minus 5 by 2 plus 1 is minus 3 by 2. F gets cancelled. 2 gets cancelled. It becomes plus minus 5 by 3. 1 minus is there, minus 5 by 3 centimeters. Sorry, minus 5 by 3. F, no. F is also there. Only F, 1F got cancelled. Only 1F got cancelled. 1F got cancelled. What 1F is remaining already. So it is minus 5 by 3F. So can you look at this image? Can you look at the image? This distance, whatever we got, is also with respect to the mirror that we are analyzing. We are analyzing with respect to this mirror. So the distance that we got, minus 5 by 3F, is also with respect to this point. Since it is minus, it is on the left side of this mirror, which is at a distance of 5 by 3F. So this length, this is at 4 by 3. 5 by 3 means it's little farther. This point is 2F, so it means it is less than 2F. 5 by 3 means it is less than 2F. So it should be somewhere here. This is 5 by 3. This length is 5 by 3F. Minus indicates it is on this side. So how much is this length? From this point to this point. What is this length? Can you tell me?
1 by 3.
This is 5 by 3. This is 4 by 3. So it should be 1 by 3F or F by 3. Correct?
Yes.
Right? So what is the meaning of this? The object, this is the object, and its image should be formed here. The image is expected to form here. For this mirror, image is expected to form here. If there is, this mirror is not there. If this plane mirror is not there, it will be forming here. With the absence of this mirror, the image is supposed to form here. Image is forming behind this mirror. Now, when you place this mirror, this image of this mirror will act as object for this. Image of this mirror will act as object for this mirror. Or rays of this object falling on this mirror after reflection, they fall on this mirror. They fall on this mirror. Since the image for this one is here, it means the rays coming from this will intersect here. I'll just draw some example, okay? And the rays, when a ray falls on this one, what happens? Let me take easy rays. If you take a ray that is falling on the pole, it will intersect at this point. Okay? If you take a parallel ray or a ray passing through focus after reflection, it will pass through this point. Something like that. Something like this. Using ray diagrams also we can understand. So that is the meaning of forming the image. But will these rays reach this object? Reach this point? Will the rays after reflection, rays coming from the object after reflection, they are supposed to meet here. But because of the presence of this mirror, will the rays go beyond the mirror? Is that possible? No. So what happens now? These rays, how will they act like? Or this object, which is actually real, this image is a real image for this mirror. For this mirror, this is a real image. But for this mirror, how is this going to behave like?
Virtual image.
Virtual what? Virtual object or virtual image?
Object.
So this is real image of concave mirror. Correct? And this image, real image, will behave as virtual object for plane mirror. Correct? The rays are supposed to intersect here, the converging rays, but they are not actually converging. They appear to converge here. For this mirror, these rays, whatever rays are falling on the plane mirror, they are from the object, or they are towards the object. See, these rays, the incident rays are because of the object. So these rays which are incident on this mirror is because of the object which is behind it. Since the object is behind, any object behind the mirror, we can call it as virtual object. For a plane mirror, we know the story, right? The object distance and image distance both are same. So now can you tell me the image location? Anyone? Can anyone tell me the image location? Can someone tell me the image location? Image distance and object distance are equal, no, in plane mirror.
Yes.
So what
Yes.
is the image object distance? Object is at a distance of f/3 behind the mirror. So where will be the image? Image also will be at a distance of f/3 in front of the mirror. For virtual object, we get a real image. For real object, we get a virtual image for plane mirror. So what is this length? This is also f/3. f/3. So can you tell me the exact location now? This is 4/3, no? 4/3 minus f. What is it? Can I say it is focus? This is exactly focus. This length is 4/3. This length is 4/3. And 4/3 from the mirror, it is at a distance of f/3. Remove f/3 from 4/3, it will be f. So final image is at a distance of f/3 from plane mirror. Is at a distance of f/3 from plane mirror. At a distance of, in the options it can be like this or it can be other way also. Final image is at a distance of f/3 from plane mirror towards right side. f/3 right side from plane mirror, or final image is at a distance of f left side from concave mirror. Both are correct. In the options they might give you this or they might give you this. Or they might also say it is at a distance, so and so distance from the center of curvature, or it may so and so distance from the focus. The options can be anything. Once you find the answer, you have to match it with the options they have given. Because there are multiple mirrors, measurement can be done from any mirror. The options they can give you from any mirror. When there are multiple mirrors, you have to be careful with the measurements. Okay. See here we got Vs minus 5/3f from here. The measurement is from here. But when you are talking about the image formation with respect to this plane mirror, you have to measure from this mirror. We have measured from this mirror as f/3. So image formation is also at f/3. When you're dealing with this mirror, don't try to calculate things from this mirror. That is the only thing you should keep in mind. Let them give any number of mirrors. Understood?
Yes, sir.
Purnashti, anything you want me to explain?
No, sir. Actually, I am getting voice. Your voice getting breaking.
The voice is breaking.
Yes, sir. I am not understanding for that.
I think my internet is fine. I think. Meghna, is it breaking for me? For you also?
You are clear from.
No, sir.
I think internet problem from your side only.
Yes, sir.
If it is a problem from my side, I will know.
Yes.
Lot. Anyway, no issues. If you want, I can share the recording. You
Yes,
can
sir.
listen to it later. Okay.
Yesterday's and today's, sir.
I'll send it.
Yes. Yes.
Okay. Shall we do one more problem before leaving? So we're going to stop this topic at the end today because we'll stop spherical mirrors topic today itself. So if there is any problem that you're not able to solve from the material, you can get back to me later. So next class is on Monday. We will start our new topic. We'll start refraction. Okay. Right. So 13. Okay. 12, 13. I think we've solved almost every question. Very good. Yeah. So let's try this one. One convex, one concave mirror. Let us try this one. Concave mirror and convex mirror focal length 10 centimeters and 15 centimeters. Concave mirror is having a focal length of 10 minus 10 centimeters. Convex length is having a focal length of, it is positive, plus 15 centimeters. And they are placed at a distance of 70 centimeters. An object AB of height 20 centimeters, sorry, 2 centimeters. Height is 2 centimeters only, it's written as 20 by mistake. Is placed at a distance of 30 centimeters from the concave mirror. First ray is incident on concave mirror. First ray is incident on concave mirror. So ray coming from this is first incident on concave mirror. Actually, the rays from this will go to this mirror as well as this mirror. Okay, the ray from this one is touching this one. So image will be formed because of this mirror. That image, because of that image, we get reflected rays. Those reflected rays will fall on this. An image will be formed for this, and because of those reflected rays, again reflected rays will form, and those reflected rays might touch this one. So image formation keeps continuously happening. So now first ray we have taken it like this. We can also take it like this also, no? Because rays from this object will be going in every direction. So rays from this object can also fall on this. Then we will be confused in calculating the images. So but images will be formed because of this mirror also. First image will be formed because of this mirror. If you remember, we have done it for plane mirror calculation. If there are two plane mirrors, image will be formed because of this mirror as well as this mirror, and the image of this mirror will form an image, will act as object for this mirror. So it continuously keeps happening. So just to avoid the confusion, what they are saying is, treat that first ray is reaching this mirror. Don't consider the ray first ray reaching this mirror. Now, this ray is from this object. It will create image for this. The image because of this mirror will act as object for this. So they are saying first ray is incident on the concave mirror, which means this is the object, and this reflected ray will fall on this mirror. Okay, and after reflection, it will go something like this. Okay, so an image is formed for this object. An image is formed for this object. That image will act as object for this. Okay, that image will act as object for this, and that as object find the image because of this only 2 times, because it happens infinite times, but we don't need to do it those many times. They're asking first ray is incident on concave and then on convex. First ray is incident because of this object. Second ray is incident on this because of image of this object. Image of this mirror is acting as object for this mirror. Okay. Right, only 2 times we have to do it. Let's do it. Now you'll understand how to deal with multiple mirrors, how to deal with those distances. Let me remove these ray diagrams. With the help of ray diagram, we can explain everything, but you don't draw unnecessarily ray diagrams because that will make it clumsy and will confuse you. Fine. So let us deal with first concave mirror, because first ray they're saying it is incident on concave. Let's deal with concave mirror first. So what is the object distance? Can you tell me? So they said that it is 30. So should we take it as 30, plus 30 or minus 30? If you understand carefully, all the confusions will be over. Is it plus 30 or minus 30? Plus 30 or minus 30? See, object is this side. Ray is coming this side. Ray is coming this side. So
Minus.
these distances are measured as positive, and this side distances is negative, correct? Or anything in front of the polished surface, we measure it negatively. That's why I was always saying anything in front of the polished surface is measured negative. The object is here, rays are coming in this direction, rays are coming in this direction. So anything measured from this pole, anything measured on this side, left side, is measured positively. Anything on the right side is measured negatively. Or anything in front of the polished surface, you just give minus sign. Anything behind the mirror, you give positive sign. So what is U? Minus 30. Is that okay? Next, height of the object is given as 2 centimeters. So U is given, F of concave mirror is also given. Let us quickly use the formula. V equal to UF by U minus F. Applying formula is the easiest part here. Writing what is U value, F value, right, with the signs, that is the important part, tricky part. So this is 30 into 10 minus into minus will become plus, divided by minus 30 plus 10 is minus 20. 0, 0 gets cancelled, is minus 15 centimeters. Minus 15 centimeters. Yeah. So minus 15 means on this side only, or towards the side of polished surface. From the pole, measure 15 centimeters. It is somewhere here. It is okay. So it is 15 centimeters from the pole. So this is 15. This length we know. So could you tell me how is the object? How is the image? Is it inverted or erect? Real object, real image. Whenever you have a real object for real image, it is always inverted, no? Magnification factor is minus V by U. Minus of V is minus 15 divided by U is minus 30, which is equal to minus half. So it is inverted. It is half of the size of this. It is something like this. So if this is 2 centimeters, how much is the length of this? Can you tell me? How much is this length? It is only 1 centimeter because magnification is minus half. Magnification height of the image is equal to m times height of the object. M is minus half into height of the object is 2 centimeters, which is equal to minus 1 centimeter. Height of the image is minus 1 centimeter. Because it is minus, I have plotted it downwards. Okay. And this is the image formation, which means rays come from this. After reflection, they intersect at this point, at this point. For this point, rays from this point will come and intersect at this point. So this image, this is the image for this object. This image will act as object for this one. This object also will act as object, agreed. But firstly, they are saying that it is, you take it as it is incident on this mirror. After reflection, rays will start, will appear like they are starting from this point. The rays appear to come from this point. So treat this as object for this mirror. Now when you're dealing with this mirror, when you're dealing with convex mirror, every length should be measured from the convex mirror. So once you know how to measure lengths, then everything else is simple. You applying formulas is the easiest part. Right. So tell me the lens convex mirror. How much is the U value? How much is the U value? You have to measure from here. This length is what is important for us. This image formed because of this mirror is acting as object for this mirror. So what is this length? You have to measure things from here. Whenever you want to apply the formula 1 by V plus 1 by U plus equal to 1 by F, that formula you apply for a mirror. Whichever mirror you are applying, you have to measure distances from that one. So what is U for this mirror? How much?
70 minus 15.
Very good. So we know this is 15, right?
55.
15. This total is 70. 70 minus 15 is 65. Length is 65, but is it in front of the mirror or behind the mirror? It is in front of the mirror. Anything in front of the mirror? Sorry, 55, right? Yeah, 55. 55. Because this is in front of this mirror, anything in front of the polished surface, you can take it negatively. And what is the focal length of convex mirror? It is plus 15. So V equal to UF by U minus F. So U is minus 15 into plus 15 divided by U is minus 55 minus F is 15. Minus 55 into 15 divided by minus 55 minus 15 is minus 70, right? So minus goes. So 5 3s, 5 14s. Okay, 55. Minus 55 into 3 is 165 divided by 14, which is roughly minus. Sorry, it is plus, no? Minus into minus is plus. So 14 ones, 14. 25 is 14 ones again. 25 is 11, 110. 14 5 70, 6 7 times, approximately 8 times, approximately 11.8 centimeters, plus 11.8 centimeters. We got it as positive. Positive means it is behind the convex mirror. It is behind the convex mirror. So what is the location? It is here, somewhere here. And what is the length? Length of this is 11.8, approximately 165 by 14 or 11.8 centimeters. behind the convex mirror. So how is it going to look like? Can you tell me how is it going to look like if you plot it? So you can calculate other things also. Magnification factor is equal to minus V by U minus 11.8 or 165 by 14. 165 by 14 divided by minus 55. Minus will go. So 55 ones, 55 threes plus 3 by 14. It is diminished. Positive sign means it is on the same side. So this is image of the first mirror. This acts as object for this one. So for this one, image will be smaller than that, but it is erect. Okay. Now they can ask us what is the total magnification after this first image and the second image. What is the total magnification factor? Whenever you are talking about magnification factor, find the magnification of the first mirror and multiply with the magnification of the second mirror. As simple as that. Okay. Or here, what is the size of the object? Magnification is equal to height of the image divided by height of the object, which is equal to 3 by 14. So height of the image for this convex mirror is equal to 3 by 14 times object for this mirror. What is the object for this mirror? It is having a size of 1 centimeter. So this is the object for this mirror, which is having 1 centimeter height. So it will be 3 by 14 centimeters. 3 by 14 centimeters is the height of the final image. Okay. So if you want the total magnification, what is the original object and final image? If you take the ratio of them, you'll get the total magnification. So 3 by 14 divided by 2, that will give you the total magnification. Or you can also do it like this. First magnification factor, second magnification factor. First magnification factor is minus half into second magnification factor is 3 by 14, which is minus 3 divided by 28. So this is height of the image, final image, divided by height of the object, initial object. So this implies height of the image, final, is equal to minus 3 by 28 times height of the original object. What is height of the original object? It is 2 centimeters, which is equal to minus 3 divided by 14 centimeters. See, that is what we got here. So overall magnification factor is minus 3 by 28. Final image size is minus 3 by 14. When there are multiple mirrors, take the magnification factor of each mirror, just multiply the magnification factors, you'll get the effective magnification. Understood? Any doubt? Any confusion? Let me know. Any confusion? Megna?
No, sir.
Try to do it on your own once. Object for one mirror will create an image. The image of one mirror is acting as object for the next one. The meaning of it is rays are coming from this. After reflection, they are converging here. And after converging, they are not stopping. No, they are leaving. They are leaving from here and they are touching this mirror. So if they are looking like converging from, they are trying to emerge from here. Once the rays are converging here, well, they will also diverge also. Once they converge, they also diverge from that place. So they look like diverging from here, which means for this mirror, rays are coming from here. Rays are coming from here, which means this point, this place will act as object for this mirror. Okay. Fine. So try to do it on your own once again. You'll be able to understand. So yeah, so one question I've left. So 14, yeah, 14 also I've left. 14 and 16, you can try it on your own. You should be able to do it. Multiple mirrors are not difficult. Only thing is, only tricky part there is you have to measure distances properly. Whatever mirror you are dealing with, you have to measure distances from that mirror. Okay, fine then. So these two questions, whatever I've left, you can try them on your own. So if you're able to solve, that's fine. Otherwise, I'll give you the idea when we meet in the next class. Okay, fine. I'll share the PDF. I forgot to share it yesterday. I'll share it today.